Hello and welcome back to Math Class with Mr. Curran. Today we're going to continue talking about solutions to systems of equations. And today we're going to specifically talk about the different types of solutions that you can have to a system of equations. So there's three different types of solutions you can have here. The first one is one solution. So you can have one solution, which means one point or one spot when two lines meet at one point or one spot. So if you watched our previous lesson, when we were graphing a system of equations, when those two lines crossed each other, that was an example of one solution. And I'll draw an example down here in a minute. But this means that the ordered pair, x comma y, is the only ordered pair that is the answer to both equations. So let me scoot this up a little bit, and I'm going to just sketch a graph of what this would look like. So if we had two lines, one like this, and one like this, that's an example of one solution. This point right here would be our one solution. That's the one spot on the graph where this point is a solution to both of these lines, or it falls on both of these lines. So on a graph, this is what a one solution system of equations would look like. Okay, now let's look at no solution. We can have a system of equation that doesn't have a solution. That's what this would be. When two lines never meet. So if these lines never meet, they never cross each other. Once again, we'll draw an example in a minute. That would be no solution. Lines that do not intersect are parallel lines. This means that there is no ordered pair that will be the answer to both equations. There's not one single point on the graph that is the same on both of your lines. Parallel lines are lines that have the same slope. So let's draw an example of that. So if we had one line going like this, and I won't be able to draw it perfectly parallel, but imagine these lines are perfectly parallel. They're both going to continue on in both directions here, but they will never touch. They will never cross. They have the same slope, or the same m value if we're trying to graph them. This is an example of what no solution would look like. All right, and then finally, infinite solutions is our last one. When two lines always meet. They're the same line, identical lines. They might look different. You have to solve them, and then they're the same, but they're the same line. This means that all ordered pairs that are the answer to the first equation will also be the answer to the second equation. So all ordered pairs are the same on both lines. Lines that have all solutions are lines that are the exact same line. The exact same line. So on a graph, it would look like this. You're graphing your line, graphing your lines. Your first one goes like this, and then you go to graph your second one, and you find it's the same thing. It's the same exact line. This is a very simple example, but that would be like you have an equation that's y equals 2x plus 4, and then your other equation is y equals 4 plus 2x. They just look different, right? But when you go to graph them, here's your m, here's your b, here's your m, here's your b. They're the same. That's just the simplest showing the simplest example. But that is what it would look like to have infinite solutions. So if you ever get an example like one of these, your solution for one solution would be an ordered pair. So your answer here, you would have to put an x comma y as your solution. Here, your solution, you would say no solution. That's your answer, no solution. If you get this one, you would say infinite solutions. Infinite solutions. All right, thanks again for coming to math class with Mr. Kura, and I look forward to talking to you again soon.